Yeah.
What are your thoughts?
Well, so I know it said something about it losing 1/3 every blank days. So I assumed you just plugged 1/3 into T, but I don't think it was that simple.
Okay, so again, a thing that we want to make sure we're breaking in this class is we want to avoid the temptation of I have a number and I see a variable, so I'm going to smash them together. We want to make instead that we're getting into the story and that we're treating the variables for what they mean, and we're treating the numbers for what they mean, and we're pulling data out as we go. So let's just start with what it's provided. So we got a sample of unknown chemical element naturally loses its mass over time. Good. So we should expect mass to go down. The relationship between the elapsed time, T, and date. So what's T mean?
Time.
Time in days specifically,
days.
right?
Yeah.
So number of days. All right, so we're going to lock that in. T is days. All right, since the mass of the sample was initially measured, okay, and it's mass M of T, so this right here, capital M means mass. M of T means mass changes.
So is M of T one variable altogether, or is T also considered its separate bit? Okay.
Nope, it's all one thing. Yep, M of T, that's a story. So it's saying that if I wanted to describe the mass is going to change as the days change.
Okay.
It's a function. So it says mass is a function of time. All right. All right, it's modeled by the following function. Good. So again, it's a function. Function also means we should get one answer.
Yeah.
Right? At least for mass. That mass should always be one. Very easy to find. Like we should always get mass is one thing. Mass can never be two things on the same moment. Right? Okay. So now we're coming down here. Complete the following sentence about, okay, so the sample loses 1/3 of its mass every question mark days. All right, so then days means which variable?
The T.
T, so we're trying to find time. That's what this is asking for.
Okay.
Okay. All right, loses 1/3 of its mass. What's that mean?
I don't know how to answer that in that context.
Okay, that's fine. Let's take a look up here. What does this all look like? Like, where do we think this function came from? What's the 900 mean, do we think?
I assume it's starting mass.
It's starting mass, right? It kind of starts to follow that structure of like principal times 1 plus rate over n to the nt. Like it's resembling this. It's repeatedly something in reference to something. So here's our repeated, here's our change. It looks like this one is changing where it's going down. That makes sense since the mass is going down. Okay, good. So we've got the 900 is our starting place, our starting mass. 900 is the starting mass. So now let's go back over here. If it loses 1/3 of the mass, what's that mean?
It would just be like 900 times 1/3, and then whatever that value is, you subtract it from 900.
Good. So 900 times 1/3 would be 300. If I subtract that, I'm at 600. So you're saying 600 is the final mass.
I guess, yeah.
Does that look good? Because if we went down to 300, we get here.
Yeah.
And then if we went down 2 more steps of 300, we'd be gone completely. So that's down 1/3. Does that look good?
Yeah. Yep.
Okay, cool. So if I'm trying to figure out where we're at when we've lost 1/3, I think that means that we have 600 is what I got after I take the 900 and I repeatedly scale it down an unknown number of days, right? Well, the only thing I've got missing in here is T, so I think we should be able to solve this. How should we solve this? How can we start to get T alone?
I assume divide both sides by 900.
All right, but let's make it less about assuming. Does it make sense that we would?
Yeah.
Okay, cool. So we'll do it because I've got multiplication. I'll divide both sides by 900. Gets that. Then what?
Multiply both sides by 27.
If we did, I don't know that it would cancel with this 27, because this 27 is actually a bunch of 27s, t repetitions of 27s, right? That exponent.
Mhm.
So I don't think multiplying is going to work its way into that parenthesis set.
I don't know, the thing that's throwing me off is that the t is an exponent, so otherwise I would just
Yeah.
say 9.
That's exactly the weird part about it. The way to work with exponents, the way to undo exponents or expose exponents is logarithms.
Okay.
So we could consider doing a logarithm of both sides. What do we remember about logarithms? Do you remember what we can do with powers and logarithms, or how any of this changes?
Wouldn't it, I assume you want to like convert it to the or it's in an exponential form, right?
Mm-hmm.
Okay.
Yeah, I think the motivation right now is that t is up here and we wish it wasn't, right?
Yeah. Wouldn't it be like log t and then the 9/27?
Close. The log 9/27 is going to stay. The nice thing about exponents in logs is that the exponent can come to the front.
Oh, that's right. Yeah.
So we've got t times natural log 9/27.
Yeah.
Equals natural log 600/900. And again, why did I choose natural log? Because it was the first one to pop in my head. Any logarithm would work. Log base 10 is fine. Log base anything else is difficult, but the calculator can carry it.
Yeah.
All right, so now we've got t in front in a nice algebra position. That's great. How do we get it alone?
Divide both sides by log of 9/27.
That's exactly right. So then I think we get something that you can throw into your calculator. So we've got natural log of 600/900 divided by natural log 9/27. Plug that in your calculator. That'll tell you t.
Okay. And normal scientific calculators can do log functions like that.
Yep. If they just say log, it's log base 10. Otherwise, it'll say ln for natural log.
I got 0.36 and then round that up to 0.37.
Good. Yep. That sounds, I think, pretty good. 2/3. I didn't run it on my end. So whatever, I will trust you on that one because I didn't run it on my end. But yeah, whatever this comes out to be, like that's it.
Okay.
Now we can double check it. Here's a good way to double check it, especially logarithms, because there's a lot to type in there and keep balanced.
Yeah.
Let's just go back over here and try it. So do 9/27 to whatever answer you got.
It's basically the same thing. It's a little bit off, but it's 0.3 repeating.
You did 900 times all that?
Oh, no. Okay, yeah, it was the same thing.
It works out to 600?
Yep.
Yep, then you're good. So what did you say that answer was?
0.37.
0.37. Okay, good. There you are. So it'd be 37 days. So a third of a day, it looks like. Man, that thing's chugging on down. Okay, cool.